For 72 seconds in August of 1977, something out there spoke to us. Then it went silent. It has been silent for 48 years. This is the longest unanswered call in human history, and the more we investigate it, the worse it gets. August 15th, 1977, Delaware, Ohio. The Big Ear radio telescope at Ohio State University is doing what it has done every night for over a decade. It is scanning a narrow band of frequencies near 1,420 megahertz, what astronomers call the hydrogen line. The single frequency they have argued since 1959 that any intelligent civilization in the galaxy would most likely use to make contact. That night, Big Ear is empty. No operator, no witnesses, just paper. The signal arrives at 22:16 Eastern Time. The telescope records it automatically, ink onto a moving roll of computer paper. The signal lasts 72 seconds, the precise amount of time it should last if it were coming from a fixed point in deep space, as the Earth rotated past it. Then the signal stops. 3 days later, an astronomer named Jerry Ehman sits down with the printouts. He runs his eyes down column after column of background radio noise, mostly zeros and ones, hour after hour of cosmic silence, rendered as numbers. And then he sees a sequence that reads 6, E, Q, U, J, 5. In the scoring system Big Ear used, normal background noise registered as a 0 or a 1. A faint signal might be a 2 or a 3. A strong terrestrial event might hit 4. 5 was rare. 6 was exceptional. E is 14. Q is 26. U is 30. J is 19. 30 times the cosmic background in a 72-second window on a frequency that should be silent. Ehman circled the column in red pen. In the margin, he wrote one word, the same word any radio astronomer on Earth would have written. Wow. Here is what makes the wow signal different from every other anomaly humans have ever recorded in space. It arrived on 1,420.4056 megahertz. The hydrogen line, the natural resonance frequency of neutral hydrogen, the most abundant substance in the universe. In 1959, two physicists at Cornell, Giuseppe Cocconi and Philip Morrison, published a paper in Nature arguing that any civilization capable of radio astronomy would already be studying this exact frequency. So if any civilization anywhere in the galaxy ever decided to broadcast a message they wanted another civilization to find, they would broadcast it on 1,420 megahertz. It would be the cosmic equivalent of a public bulletin board. The wow signal hit that frequency. Exactly. It was narrowband, at which natural cosmic sources almost never are. It was unmodulated, which a deliberate first beacon transmitting before any conversation would be. It came from a region of sky with no known stars, no known planets, no known transmitters. It came from nowhere. It came once. It never came again. Within 48 hours of his discovery, Ehman and the Big Ear team had repointed the telescope at the same coordinates. They listened for hours. Nothing. They returned the next night. Nothing. They returned every clear night for the next month. Silence. Other observatories joined the search. The Arecibo radio telescope, at the time the largest radio dish on Earth, pointed at the patch of sky in 1995, in 1996, again in 1999, silence each time. The Very Large Array in New Mexico tried in 1995, silence. In 2017, a research team from the SETI Institute used the Allen Telescope Array, 100 radio dishes operating in parallel. They listened for over 100 hours, they heard nothing. More than 50 independent searches over 48 years. The signal has never repeated. For decades, the simplest explanation was that the wow signal had been a mistake, a reflection, a satellite, a military radar bouncing off space debris, some terrestrial source that had snuck into the data and been mistaken for something more. In 2017, a physicist named Antonio Paris proposed a clean solution. He published a paper arguing that the signal had come from one of two comets, 266 P. Christensen and 335 P. Gibbs, both unknown in 1977, both passing through approximately the right region of sky that summer. Hydrogen released from a comet's coma could, in theory, produce a 1,420 megahertz signature. The paper made headlines around the world. The wow signal had been solved. Closed file. It was wrong. Other astronomers checked Paris's math. The comets had not been where he claimed they were on August 15, 1977. The hydrogen densities he required were physically impossible. The Cassini spacecraft had since flown by similar comets and found nothing resembling the wow profile. By 2018, the comet hypothesis was quietly retracted. The simplest explanation did not work. None of the simple explanations have ever worked. In 2020, a Spanish amateur astronomer named Alberto Caballero went looking for something specific. He overlaid the wow signal's coordinates onto data from the Gaia spacecraft, the most precise map of stars in the Milky Way ever assembled. He was searching for stars that resemble our Sun, solar analogues, the kind of star that, if it had planets, might have planets capable of carrying liquid water on their surface. Inside the wow signal's beam footprint, Caballero found one match, a G-type main sequence star, roughly the same temperature, mass, and age as our Sun, located 1,800 light-years from Earth in the constellation Sagittarius. It is a sun, with the rough conditions of our Sun, in the exact direction the signal came from. If the wow signal was sent deliberately, and if it came from the surface of a planet orbiting that star, then it was transmitted around the year 200 AD, when Rome ruled the known world, when the Antonine Plague was killing a fifth of the empire. The signal travelled for 18 centuries through the vacuum of interstellar space. It crossed paths with Earth for 72 seconds. In 2012, on the 35th anniversary of the original detection, the Arecibo radio telescope transmitted a response. The reply, travelling at the speed of light, will reach the source region around the year 3812. If anyone is still listening, if anyone was ever listening, if anyone was ever there at all.